Good morning, good evening, or good night, depending on wherever you are. It's such an honor to be the first to open the series of outstanding talks here at Dapr Day. For the next 20 minutes or so, it will be my pleasure to tell you a story and some tips regarding Dapr-based production applications. My name is Alex, and I am what Microsoft calls a regional director and the most valuable professional. But don't be fooled into believing that I work for Microsoft. I most certainly do not. I am based in Romania, or Transylvania to be specific, and I run a company of highly talented software developers called Key Ticket Solutions. Among other things, I also am one of the global Azure admins, a worldwide community of Azure experts who organize yearly Global Azure. If you're new to Azure, make sure to search for a Global Azure chapter near you. Or if you're someone who loves to bring people together, put a pin on the Global Azure map and fellow Azure enthusiasts will come together at your location. Last year, Global Azure was organized worldwide in 6 continents and brought together over 480 free speakers who delivered around 500 sessions or so, all at the same time throughout the same 3 days. Now that's what I call community. These are all people who deserve the kudos, friends, and it's thanks to their hard work and passion that Global Azure is such a massive event and that Azure received so much love from the communities worldwide. But enough about that. Now, during this session, I'll tell you a story about an application which worked perfectly fine, and then we decided to make it not work. We effectively decomposed it into microservices, and we Dapr-based it. But it failed the moment we pre-provisioned it in the pre-production environment. So here's the deal. The application was initially comprised of an API serving not 1, not 2, but 4 different UI layers targeted for different audiences. And additionally, there was a second API which powers an application that has a completely different logic, but must share the same data set. And lastly, there are numerous background services which are either triggered or are polling the same API to retrieve the information utilized by them. So for instance, there's a notification service which usually gets triggered each time something happens in the API. For example, upon data entry, when the data expires, and so on. Now, what initially seemed like a good idea because we would only write the authorization logic in the logging layer once, quickly turned into a bit of a nightmare because of the highly volatile deployments and many teams collaborating on the same code base. It was therefore kind of a no-brainer that we had to quickly go back to the drawing board and we had to reconsider the design. Now, thankfully, we already were experienced enough with microservices as well as with Dapr, and enhancing the application with Dapr's capability was definitely a no-brainer. I kid you not, it took less than a sprint to get everything properly set up and redesigned with zero technical debt on the architectural side at least, side of things at least. But before we get our hands dirty, let's cut to the chase. Developing microservices should not be done just because monolithic applications are the worst. In fact, they're not bad at all, despite the word monolith having gained a negative connotation. You know which apps I mean. Those pesky 3-tier, 4-tier, N-tier applications. Specifically, one layer for presentation like a web app, which consumes the output of another layer, specifically running the business logic, which we usually refer to as an API, which in turn consumes the output of another application, such as the data layer. And here's the deal. These monolithic applications, they're not entirely that bad. I mean, seriously, we gotta give them credit for running mission-critical applications for the past few decades. And in all fairness, the world as we know it today was based on these kind of applications for so many years. Of course, we didn't have Netflix and Spotify decades ago, but nevertheless, these were applications that were perfectly fine. They work and they get the job done. And even more, microservices, they're anything but easy to develop. On one hand, the sole idea of segregation of work in forms of single responsibility APIs in the so-called bounded context and the segregation of data sets into independent data structures is an extremely easy thing to say, but incredibly difficult thing to achieve. Specifically, assuming we would exactly know how to develop microservices, we would hit a few problems dead on. For starters, if we would implement microservices, but our basic understanding of solid principle wasn't as strong, we would end up having a ton of integration points. You know what I mean? Like caching and messaging queues. These are all particularly fun to develop because once you get your hands dirty with asynchronous programming and reactive programming, you pretty much never want to stop. And you see the whole application as a chain of events that can be put into asynchronous programming style applications. And this includes third-party APIs, secret repositories, and whatnot. But they all must be implemented, and they all different SDKs, different APIs. So to make things even worse, Each one of these technologies comes with its own SDK, and each one has its own specificity. To make things really chaotic, each one has its own cadence, and with its own application lifecycle, which features can improve, they can also dramatically limit the functionality of your own application. And when you start implementing all kinds of different technologies, different APIs and different libraries, you realize quickly that you're writing a boilerplate code at an exponentially higher rate than you typically did in the monolithical world. Specifically due to the lack of the right tools, there's a tendency that a feature might take a sprint to develop in the monolithical way, and it might actually take several sprints to get right and integrated with those rest of services in a microservices-based app. So why did we even choose to split the API into smaller components? Well, here's the deal. Number one, we had way too many moving parts in a single project. We had way too many contributors to a single project. We had way too much redundant code written, even in a monolithical application. We had way too many dependencies and zero responsibility whatsoever, even though we had a lot of contributors. Effectively, we had a ton of friction. Now, I trust most of you already know what Dapr is, because you're at the Dapr Day. As you know, Dapr stands for Distributed Application Runtime. It is a portable, serverless, event-driven runtime that makes it easy for developers to build resilient, stateless, and stateful microservices that run on the cloud and edge, and also embraces the diversity of languages and developer frameworks. Dapr codifies the best practices for building microservices applications into open, independent building blocks that enable you to build portable applications with the language and framework of your choice. And each building block is independent, and you can use one or some or even all of the building blocks inside your own app. You gotta remember the goals Dapr has. Number one, they want to enable developers using any language or framework to write distributed applications. And they want to make it easy for you. Second, they want to solve the hard problems developers face building microservices applications by providing the best practice building blocks. They want to be community-driven, to always be open and vendor-neutral. They want to gain new contributors in an organic fashion. They want to provide consistency and portability through open APIs. They want to be platform agnostic across cloud and edge, so on-prem as well. They want to embrace extensibility and provide pluggable components without any vendor lock-in whatsoever. And most certainly, they also want to enable edge and IoT scenarios by being highly performant and very lightweight. Last but not least, they want to be incrementally adoptable inside the existing code. So no need to write greenfield applications on the applications that have been running your business for the past decade or so. Now, what sold us on Dapr, you might ask? Well, first and foremost, all that marketing big selling point that you heard before, but also we loved the ability of having pluggable technology stacks. For instance, in our dev environment, we decided to use RabbitMQ, and we went with that, but we knew RabbitMQ was not specifically good enough for our production environments. And we didn't know what technology we're going to go for the message queues in our prod environments. So having the ability of swapping components was just simply blissful. Then from the organizational standpoint, each team was responsible for a component, and we usually had smaller heterogeneous teams, meaning that each team member has vast expertise in a lot of different areas. So using Dapr, it also meant that we were decoupling things. Okay, enough intros. Let's get into the good stuff. Dapr support for Kubernetes is aligned with Kubernetes versions queue policy. This might sound very technical and difficult, but here's the catch. In a highly available cluster, the newest and the oldest kube API server instances must be within minor version. Now, from the kubelet, which is that small component that runs alongside each node inside your cluster, the kubelet must never be newer than the kube API server, and the kubelet may only be up to 3 versions older than the kube API server. There's a caveat here that if you're running 1.25 or newer, Kubernetes then it can be 2 minor versions older than the kube API server. Similarly, for the kube proxy, it must not be newer than the kube API server, and the kube proxy, which you know is responsible for the networking side of things, may be up to 3 versions older than the kube API server. So that 3 minor versions is always like a magic number in Kubernetes, and it kind of works the same way in Dapr as well. The kube proxy may be up to 3 versions older than or newer than the kubelet instances it runs alongside. And again, if you're running 1.25 or newer, it may only be 2 versions or older, maybe 2 versions older or newer than the kubelet instance it runs alongside. Now, the same principle applies to the kubelet controller manager, to the kube scheduler, and the cloud controller manager. They must not be newer than the kube API server instances they communicate with. Now, you're not expected to know all of these numbers and the version numbers and whatnot, but the key takeaway here is that there is the same version skew policy in Dapr as there is in Kubernetes. However, you must keep in mind that you must always have resource settings as a starting point. And the numbers you see here are good starting points. In my opinion, you should always perform your individual testing to find the right values for your environment, because they might differ. When you're installing Dapr using Helm, one thing to keep in mind, and we learned this through the trenches, is that there's no default limits. So effectively, installing Dapr through Helm means that Dapr can literally cannibalize your entire infrastructure and your entire set of resources. It should never happen, but misconfiguration sometimes does occur. Also, there's some optional components like the placement, the sentry, and the dashboard, which will be super useful, especially if you're running actors for the placement and if you want to get some more operational things done. You should always set resource assignments for the Dapr sidecar using the supported annotations. These annotations usually go alongside the sidecar CPU limit, sidecar memory limit, sidecar CPU request, and sidecar memory request. And if they're not set, then the Dapr sidecar would run without resource settings, which obviously may lead to a lot of different issues. For the production-ready setups, it's strongly recommended that you configure these settings. Alongside the same lines, with soft memory limits on the Dapr sidecar, when you set them up, you effectively would have this garbage collector free up the memory once it exceeds the limit instead of actually waiting for it to double the last amount of memory present in the heap when it was run. This may again sound very technical, but it's very important because if you wait for the default behavior of the garbage collector that is used in Go, you can inevitably end up having OOM kill events with your containers and with obviously your pods as well. Now, obviously we verified all of these production-ready deployment tips, and we also went further to make sure that we had mutual TLS enabled, MTLS. Dapr has MTLS on by default, and you can learn more about bringing only your own certificates. We also made sure that the application to the Dapr API authentication was enabled, because this has to be enabled to make sure that you secure the Dapr API from unauthorized access. Sometimes there is attacks from within your infrastructure. We also made sure that the Dapr to the API that we wrote was also authenticated. This is also very important because you must let Dapr know that it's communicating with authorized applications. And again, you'd be using the same token authentication principles. We had component secret configured in a secret store, and we never hard-coded any secrets in our component YAML files. And we also had the Dapr control plane installed on a dedicated namespace, for instance, Dapr system, which we commonly use, rather than having it in the default namespace or the application namespaces. Dapr also supports scope components for certain applications. Even though it's not required, it's a good practice. Now here's the deal. We did all of that, and this is good. And everything seemed fine, especially in the dev environment. But once the refactoring of our application was done and it was fully Daprized to be production ready, we deployed it in the pre-production environment just to learn that it didn't get any Dapr containers injecting the application's pod. Now, clearly, such a situation usually suggests that there might be an error indicated in the sidecar injector, right? Here's the log we saw. Reading through the logs, the only triggering part seemed to be unable to get SA tecton pipelines controller UID. It's a tongue twister, I'll give you that. And it's a bit of mumbo jumbo even. Now, I believe that the very next thing we did was the typical thing anyone else would do as well. Namely, Google on Bing, unable to get SA tecton pipelines controller UID, only to come across the first result of the query, which is a GitHub issue titled Dapr sidecar not injecting the pod. See how we didn't even specify Dapr as an issue in the query, and yet the first result was referring to this very same problem? Sure enough, the issue was closed, which usually is a good sign. And as we scrolled all the way to the bottom of the issue, this was a very long thread, one of the suggestions, and obviously a lot of people had a lot of different culprits, but nevertheless, sometimes, as it turned out, we learned that there was an extra label, at least for the people who committed and commented on this issue. Should we have had any additional labels? Everything was working in that environment. Clearly, they must be using the same labels everywhere, right? I mean, right? Time to compare and contrast. Here, on the left-hand side, what you see is everything in terms of logs from the sidecar injector running in the dev environment. On the right-hand side, the sidecar injector logs for the pre-production environment. And by the looks of it, it seems that the sidecar injector isn't even getting triggered to do its job. Now, either that, or we have another pre-Satya typical Microsoft situation where a product only logs success and fails to even log errors. You know what I'm talking about. So what should we do next? Well, Time to compare some more. I trust everyone else would do the same thing and would probably take it through the same approaches. What you have here is the pod's description. On the left-hand side, the description clearly states 2 containers in the pod. On the right-hand side, there's a single container in the pod. So yet again, this suggests that there is literally no sidecar container injected. Even more so, the missing labels are usually an indication that the sidecar failed to properly see the annotations and respond to them. This made us think. Either the annotations are triggered on the sidecar injector because the sidecar injector isn't accessible for some obscure reason, which we haven't figured out yet, or the annotations are completely wrong. But the annotations seemed fine. Wait, what if the annotations are there before Dapr was installed? As it turns out, if your pod spec template is annotated correctly and you still don't see the sidecar injected, you must make sure that Dapr was deployed to the cluster before your deployment or the pod were deployed. If this is the case, usually restarting the pods will fix the issue. So I guess it's time to reinstall. And you know what? Let's even reinstall Dapr. So first, we removed all the charts related to our application, then we reinstalled Dapr just to be sure, and then installed the application. And nothing. The sidecars were still not injected. I guess it's time to Google some more. Aha, another issue. It even says on prod environment. We're getting closer, aren't we? Now, the issue here suggests that a firewall might be preventing the sidecar injection. Of course, this makes sense. However, we didn't have such a firewall. We even SSH'd the masters just to make sure. We even went as far as reinstalling everything from scratch, again. And this included Dapr and all of its dependencies. And again, there was no error on the sidecar injector pod, which we would normally expect to tell us why something would fail regarding the injection. So it was not a firewall issue. Should we maybe blame the CNI? We've, in this case, I didn't tell you this before, but this was a vanilla installation of Kubernetes. No distro, no flavor, no easy installation process whatsoever. It was through the trenches. So let's reinstall everything and leave Weave out and replace it with Calico. And as you'd expect, still not working. All ports were properly configured, but still not working. Now here's the deal. In Kubernetes, there's this concept of an admission controller, which intercepts the request to the API server in Kubernetes prior to the persistence of the object, and after the request is authenticated and authorized. These controllers may be validating, they may be mutating, or they may be doing both. Mutating controllers can modify objects, and they can actually validate the request to make sure that the request should actually go through. These controllers can also block some custom verbs, such as a request connecting to a pod using the API server proxy. These admission controllers do not and cannot block requests to read, but they can block things from getting changed, which would be the case of the injection of the sidecar. They also proceed in 2 phases. In the first phase, the mutating admission controllers are run, and in the second phase, there's the validation admission controller, which is executed, and if the controller in either phase rejects the request, the entire request is rejected immediately and an error is returned to the end user. Now, frankly, all of this conversation is getting me a bit anxious, because we're talking about some super techy stuff here, like level 400 Kubernetes deep. Let's think about this once more. Could it be that the request is somehow getting blocked somewhere and never makes it to the sidecar injector? There's no firewall. What could block the request then? Maybe, you know what, it's not really an admission configuration or an ACL problem. But wait. Dapr, like other service meshes, relies on Kubernetes to get the component triggered to do stuff. I know what you're about to say. Dapr is not a service mesh. Even though they do offer some overlapping capabilities, Dapr is not a service mesh. I know. A service mesh is defined as a networking service mesh, and unlike a service mesh which is focused on networking components and concerns, Dapr is focused on providing building blocks that makes it easy for developers to build applications and microservices. Cool. But here's the deal. Dapr is developer-centric, right? Versus a service mesh which is not. But even though conceptually they're different, the inner workings, to a very large extent, are the same. So, you know what? Let's go back to the docs and see if the docs can help. Because in all fairness, we should have read those docs first. Hey, wait, this is on the docs. This might be promising. Let's scroll some more. That didn't really help. Because it's all about things that we already did. There's nothing new to this. But this got me thinking. You know what? There's one place we haven't looked into, namely the API server logs. Let's read through those. Now, as it turns out, in the API server logs, when you read the API server logs, we did actually get everything we were looking for. It told us that it couldn't call the sidecar injector. It told us that it was getting a 403 back. And after some detailed network troubleshooting, we even learned that the 403 was actually generated by a proxy, which the requests went through. And this was because an HTTP proxy environment variable was picked up from the host when Kubernetes was installed, and it persisted the host environment variables in the API server prod. Now, thus, the internal requests were getting to the proxy, which had no idea how to route the requests back to the sidecar injector, and there was no route back through the net whatsoever. Now, sure enough, removing an extra environment variable, we learned about by running a kubectl describe pod and restarting the API server, it got us back in business. It might have taken me probably the past 5 or 10 minutes or so to talk about this, but the level of frustration we accumulated, the lack of insights into someone else's infrastructure, was probably way too high to even mention. What did we learn though? API server logs are priceless, and people always forget about looking into those logs, and they expect all of the logs to come from other places. Since we talked about logs, Dapr uses OpenTelemetry and Zipkin protocols for the distributed traces. OpenTelemetry is the industry standard and is the recommended trace protocol to use. Now, most observability tools support OTel, and this includes Google Cloud Operations, AWS X-Ray, Azure Monitor, New Relic, Datadog, Zipkin, Jaeger, SignalFX, and many different more. The diagram that you see here pretty much demonstrates how Dapr, using OpenTelemetry and Zipkin protocols, integrates with multiple observability tools. And these scenarios can be utilized for so many different things, like tracing, service invocation, PubSub APIs. You can flow trace context between services that use these APIs. And there are commonly 2 scenarios for how tracing is utilized. Either Dapr generates a trace context you propagate and trace context to another service, or you can generate a trace context and Dapr propagates the trace context to a service. Either approach doesn't really matter as long as you use these. Now, if you have any questions, I'll be more than happy to take them, and I'll be here to assist. This was definitely something super interesting, at least in my opinion, to learn from, going through the trenches. Friends, I'll be hanging around to answer questions, but please, make sure to also join the Discord channel. Dapr's community is super wide, super open, and they're more than happy to assist in whatever questions you might have. Happy Dapr Day, and let's keep the conversation going. As I told you, there's an active community on Discord supporting, helping, and listening to your pain points, requirements, ideas, whatever they are. I urge you to join Dapr's community on Discord. Thank you all for streaming in, and happy Dapr Day.